out. My name is Colonel Chris Beck, and I'm the commander of the Louisville District. I want to take a second and introduce my peer.
Good afternoon. I'm Lieutenant Commander Heather Stratton with the Coast Guard Marine Safety Unit in Paducah.
And it's really important that the Coast Guard is here with us, because I'll start out by saying, as I lay out what we've done over the last couple of days, this has absolutely been a team effort. Between the Coast Guard, between the Corps of Engineers, TVA has been critical, other districts in our region have been critical. This has only been a success because of all that teamwork. And frankly, industry's been very helpful too. They provided a lot of patience dealing with us. So I want to give you some quick background of what we've done, or what you're looking at, what we've done over the last couple of days. And then I've got to end with a good news story, because about 6 hours ago we weren't sure how this briefing would go, and things went extremely well this morning. So behind me, what you see is Lock and Dam 52. It is one of the last two low lift dams on the Ohio River. We had upwards of 53, which is about 35 miles downstream. Those are the last two left. They'll be replaced by Olmsted in about the next 2 to 4 years. But they're our last two. And as you can also see behind me, there's the steam going up in the air. This is one of the last places we still use a steam-powered vessel. So that's how old this is. This lock and dam was constructed originally in the 1920s. We added a chamber, a 1,200-foot lock chamber in the 70s, and that was added as a, quote, temporary chamber to last about 15 years. Obviously, we've passed that. So the team down here, led by the lockmaster, Luther Helland, and the corresponding team at 53, every year do yeoman's work to make this facility run. It's one of the busiest locations on the inland waterways. We pass about 90 million tons of cargo through here every year. So it's critical to both this region, to industry, and the nation. So with that, what we encountered this year, mid-August, we went to raise the Wicket Dam. And let me orient you to the dam behind me. What you see is basically the wooden planks are called wickets. And there's two sections of that dam. The first section, closest to us on the Illinois side, working across to Kentucky, is the navigation pass. That's about 1,200 feet of wickets. Each wicket is about 4 feet wide and about 24 feet tall. And it's exactly what it says. They're wooden wickets. And then you get to the far side, on the Kentucky side, and that's called the weir wicket side. And it's made up of several different sizes of wickets, but the dam itself is designed so that as the pool goes down, as the water coming into this dam goes down, in order to maintain the 9-foot minimum depth we're required for industry, we raise the wickets. It works like a bathtub, and it keeps the water in there. So the way the dam is designed is we will, about 6 months of the year, give or take a little bit, the nav pass wickets are down. Industry passes up and down this lock as if it weren't even here. When we raise the wickets, then we lock them through the chamber. The weir wickets on the far side, which aren't as big as the nav pass wickets, are designed to control that pool. So we can put them up and down a little easier in order to keep pool for navigation to pass through. So about mid-August this year, we started raising the wickets. And it's not unusual that we have some gaps. They're very old structures. We replaced about half of them last year, but they're very old. So it's not unusual at all that we try to pick one up and it doesn't come up, or we end up with a small gap of 2 or 3. Unfortunately, this year in mid-August, we raised them and we ended up with a gap of 3 with one that would not raise, and there were other wickets on the far side of it that we could not get to. So we ended up, the bottom line is we ended up with a 42 gap hole, which is way too large for us to maintain the pool. So we've gone through a lot of gyrations of planning, a lot of very detailed analysis, a lot of, as I said earlier, working with stakeholders, to include the Coast Guard and industry, to ensure that we developed as thorough a plan as possible. Because, as I said, we work with steam-powered equipment here, and really this is a brute force operation. So we wanted to be sure that we maintained the safety of our employees while at the same time preserving this for industry. And we really had two options. We normally lower the dam in the October-November timeframe. Option one was we could kind of ride it out and see what happened. We estimated that the impact to industry would be significant. It'd be very unpredictable as well. So the other option was we could aggressively try and make the repairs and raise the rest of the dam, which is what we did this morning. When we talked to industry yesterday, when we finished up our planning, we were at a point where we thought we'd be out for about 96 hours. Due to a lot of cooperation with a lot of stakeholders, we were able to successfully raise the wickets that were down this morning. We've got all but about 10 of them up, and those 10 are out or missing or won't be raised, and that's very normal for any given year. So the bottom line is we have a dam right now that'll hold pool as of about 2 hours ago. And we think in about the next 8 to 10 hours, we'll be able to again pass industry through Lock and Dam 52, which is well earlier than we had said we would. So right now, again, it's a good news story. Our operation was successful. We had planned a kind of a multi-phase operation. If the first part didn't work, we had a plan B and a plan C. Fortunately, plan A worked very, very well and safely. Again, joint operation between us and the Coast Guard and TVA and other districts in our region, but the bottom line is it went successful. We were able to raise the wickets, and we're now going to be able to make it to the fall when we normally put this dam down. We're going through some additional operations now just to be sure we can operate efficiently and effectively. We're going to try and make some repairs, but at the end of the day right now we can operate our dam, so it's a good news story. So with that, I'll be more than happy to take any questions.
So when will this be opening back up then to boat traffic?
So we're estimating about 8 to 10 hours from now. What we had to do to make these repairs is we had to close Smithland Lock and Dam is about 35 river miles upstream, and this pool is also fed by Barkley and Kentucky lakes. So we closed those off to minimal flow. So we had very little water coming in this morning, which allowed us to raise those wickets. Right now, what we're in the process of doing is building that back up so we can get enough water to pass the boats through. So about 8 to 10 hours from now.
What impact has this had on commerce and trade?
I would tell you very little. Now, I won't say none because there has been a limitation to passing industry, but I'll tell you it's been very mitigated. What we've done is we started working with industry very early on when we identified this problem. We are actually having coordination calls with them daily right now. So they've prioritized their loads. We moved traffic up until last night if it was a critical load. So really and truly right now our queue coming down river and going up river is almost normal what it would be. We've got about 10 or 11 boats waiting to come downstream and about 10 or 11 boats waiting to come upstream. And that's not all that far off of what it normally is. So it's been an impact, but really no significant impact that industry wouldn't normally work through.
What, if any, has the effect been on water treatment facilities nearby?
Good question. Unfortunately, I can tell you none. One of the things that the Coast Guard was absolutely critical in helping us with is they basically went from here all the way up to Smithland and engaged every stakeholder. Because there's not only the power plants, there's Paducah that draws water, there's several other communities and businesses that draw water from the Ohio in this pool. And we've coordinated very closely with them through the emergency management in both Illinois and Kentucky, and we have not had an impact on any of them.
And have you had any response from businesses, that are shipping things or anything like that?
No, we haven't, and that was another thing we were very concerned about and why we communicated so much with industry, because we wanted to be sure that they were communicating with their stakeholders. If there was a requirement to process a key load through, then we were prepared to do that. Now, as of this morning, we didn't have enough depth to pass load, but like I said, it's probably been less than 24 hours where we've been in that condition. Prior to that point, we were passing key traffic, so if a stakeholder or industry came on board and said, hey, I need to pass this load, we did that.
And have either of you dealt with a situation like this before?
I can speak personally for me, and I can speak for my team here. We haven't dealt with this dramatic a situation. We have this problem every year. It's unfortunately it's hit or miss when they go to pick up wickets, whether they come up or not sometimes. But we have not had this large a hole before. So this is the first time, at least myself and this crew have had to work through a problem like that.
And the 3 wickets that broke free of their bases, were those wooden wickets or steel wickets?
They're all wooden wickets on this dam. So they were wooden wickets, and really the biggest problem typically isn't the wood, it's where it ties into the foundation or the river. It's the concrete and the bolts down there that normally give way.
And how often are those wickets replaced?
It really depends. Last year we replaced almost half of them. You can see right now we've got a contractor's boat in the water. Our goal this year is to continue working on that. A lot of it is, at least in recent years, is replace as required. But last year we really took concerted effort to get ahead of that and really replace as many as we could. We were limited to about half of them, not only financially, but also time we could work in the river. So we're going to get back after that this year.
And do you know of any other dams that use the same system or a similar one?
Well, like I said, right now 52, which is about 53, which is about 35 miles downstream, is the exact same setup. Olmsted will have a similar setup, and it'll have wickets, and they'll be raised manually with a lifter similar to this. Those will be steel wickets, though.
So you'll still be raising them by hand?
Well, we'll be raising them by hand in as much as you can see going, well, you can't see it from here, going across the river on our workboat. We have a hydraulic excavator that you reach down into the river, which is, frankly, a new system as of about 3 or 4 years ago here. Prior to that, the guys did. They had a hook, and they lowered it right down in the water manually. So it has advanced a little bit, but it's still very, very labor-intensive work.
And when do you expect Olmsted to be complete?
Right now, Olmsted will be operational to be able to pass traffic October of 2018.
Okay, and with that, what will happen to this dam in Smithland?
So when I say October of 2018 operational, that's not the completion date. We normally report the completion date of 2022, and that's to account for exactly what you said. The completion of Olmsted includes removal of 52 and 53, so the navigation channel is open and clear and doesn't have any hindrances to navigation.
What will be the economic benefits of
So when Olmsted's said and done, it'll be about $640 million a year that it'll pass through there. So the good news is with that project, it's been a significant investment for the nation, obviously, but it'll repay itself pretty quickly.
And how are you able to project that number or that figure?
It's really based on the history of what's come through this area and this hub. As I said when I started, this area being the confluence of the Mississippi and the Ohio is one of the critical nodes on the entire inland waterways navigation system. We pass more than 90 million tons a year, and so those numbers of $640 million were really developed through a detailed economic analysis when we did our reauthorization back in 2010 and 11.
And in 2013, Kentucky received a pretty low grade on the American Society of Civil Engineers infrastructure report. Is Olmsted part of the project to, improve that, or is there?
Absolutely, and I would tell you that the nation received a low grade in a lot of those areas with the American Society of Civil Engineers. But Olmsted is exactly that. So like I said, 52 and 53 are the last two low lift dams from the original Ohio. Olmsted is the last phase of replacing all those. It was a master plan of the Ohio River and a navigation requirement. So yes, Olmsted's critical to getting these out of service and having that new system in place.
And are there any other ongoing projects to help try to improve that grade?
As far as on the river?
Yeah,
we can within the Louisville district. We consistently do general operations and maintenance repairs. Significant projects within our region. There are several going on. Obviously, we've got Olmsted up in the Pittsburgh area. They're working on the lower Monongahela project, and then also down in the Nashville area, they're also looking at Chickamauga Lock and Kentucky Lock down there as well. So there are several significant infrastructure projects up and down the river, and then the efforts of folks like these out here every day and every year with the operations and maintenance.
And while I have a monopoly on your time, how many inspectors do you have for Kentucky to inspect the dams?
Okay, so I don't really know how to answer that because I don't have anybody dedicated as an inspector. What we do is we have engineering teams that come out and do what we call periodic inspections. So there are normal engineers in our organization. They do design work day to day, and then what they will do is they come out and not only these facilities but also our dams. We have a cycle. Usually every 5 years they come out and do a very detailed analysis, a very detailed inspection. It's a challenge at a lot of these lock facilities. Years ago we used to dewater them, and when you can dewater, you can climb down in and see a lot of things. Fiscally, we can't dewater quite as much as we used to, so it's a little bit more challenging. But they get inspected like I said, on a recurring basis. And if there's ever a challenge at all with we hear something that we shouldn't hear or something happens, these guys have engineers that are down here. As a matter of fact, Brad Stout, who's not out here right now, has been down here for the last 3 weeks helping out, and we dispatch guys right away.
And how often are they inspected? You said periodically?
It's normally every 5-year interval for periodic inspections, like I said, of both our locks and our lakes. And it's when a team comes down and they look from head to toe on everything.
And how often can you let that water down to do a full inspection, like you said?
That's more rare. That's not necessarily a recurring cycle. It used to be, but it's not anymore. Fiscally, it's more challenging to do. So I can't give you a specific number, but if we identify a challenge, particularly with the periodic inspections, then we'll go ahead and dewater the lock and dam or the lock chamber and inspect it fully.
Have you found better ways to inspect it so that you don't have to let the water down things that aren't, as fiscally straining?
Well, it starts with the guys on the site. There's nobody that knows these facilities as well as the 20 or so folks that have worked here for years. They can tell you whether a noise is something significant or it's more significant if it doesn't make a noise. So that's where it starts. And when those guys identify a challenge, then we bring the engineers down. So as far as to say, is there a better way? Really, it's that constant communication. There's nothing that beats, at the end of the day, dewatering and be able to climb in, around, and on that stuff. But that early detection and that communication and getting, like I said, engineers from our headquarters in Louisville down here quickly are the ways that we mitigate that inability to dewater quite as frequently as we used to.
Okay.
All right.
I know the closure's not going to last as long as you guys expected, but it's still 8 to 10 hours. So for the general public, if they come down here or to the Smithland Dam, what would they notice? Any changes or differences today while it's closed?
Are you talking if they came through in a normal recreational boat?
No, if they just were to come down here, look out at the dam, are they going to notice anything?
No, they won't notice any difference. As a matter of fact, I've been down here several times, and all I noticed this morning was it looked a little bit lower. You're not going to see much difference at all, and that I would tell you is good news. So, no, not really.
And how much did you guys lower the water this morning? Sorry if you already answered.
No, that's fine. So our normal pool is about an elevation of about 302. We were at 298.5 this morning, so we lowered about 4 or 5 feet. And that was critical because downstream the water was a little bit higher, and that equilibrium allowed us to get in and work with a lower head differential as well as a lower, lesser velocity, and made it much safer working conditions.
And again, it's still closed today, and I know that you guys, the release kept mentioning commodities that the traffic would be carrying. What do you mean by commodities, and will those still be impacted?
They will temporarily, like I said. So commodities can range anything. Industry moves quite a bit up and down the river. From coal, they'll move any type of to fuels, grains, all those type of things up and down the river, and it's critical. Each one of these barges you see going by that's got a configuration of about 15 different barge compartments is equal to over 1,000 trucks on the road. So this inland waterways is critical to our nation. So there is a little bit of a delay. Like I said, starting about last night, we had to stop moving traffic through. With the fact that we're able to open up in about 8 to 10 hours, I'm very, very pleased that it was a minimal impact to industry. And right now, the queue to come up or down river is not far off of what it has typically just coming through this facility.
Okay, when we look out there right now, what is that we're seeing? Is that some of the work they're doing?
It is. So you see the wooden pieces sticking up. That's the wickets. And then what you see is some of our work boats. So where that work boat is positioned right now is on the weir wicket portion. And again, those are smaller wickets. They're designed to allow us to control the pool, the upper pool and the upper pool without messing around with the nav wickets, which are a little bit more dramatic a process. So they're working on the weir wickets right now. And what they're doing is they're trying to unpin some of those wickets so that when the pool gets higher, those wickets will be tripped, and it'll allow us to keep a better flow through the facility. Any other questions?
What you've learned here today, are you concerned that you might have some similar problems down at 53? I mean, you said these are wooden, but those are steel, but it's the bolts that are the issues.
Now, let me clarify. The ones at 53 are not steel. They're wooden. The ones at Olmsted are steel. Am I concerned? I am less concerned, and there's two reasons why. One, similar to what we did last year where we replaced about 70 or so wickets here, we replaced about 110 down there last year in an attempt to be proactive and be sure that we could raise it if we needed to. Additionally, the hydraulic conditions are different down there. With Olmsted just downriver, literally less than a mile, we very rarely have to put that dam up. So there's certainly a risk. I think we have been very proactive in addressing that risk, and I also think the chances of us having to raise that particular dam are minimal. So that spins to the next question of what are we doing here to prevent this in the future? And what I would tell you, again, you can see the boat. There's a boat slightly upriver. That's a contractor's boat. So what we're doing with that boat is we're placing anchors upstream. And what those anchors will let us do is the challenge we have is if the gap gets too large with the wickets, we can't straddle it and get across it to continue work. Those anchors that the contractor are putting in will allow us in the future, if we run into a problem similar to what we did today, we'll have the ability to straddle that hole and work across it and hopefully get that back up. So we're trying to be proactive to ensure that we don't encounter this here, let alone at any other site.
What is the benefit of using a design system for the dam from the 1920s? Have you found any other systems or designs that are better that you're looking at or anything like that?
That's a good question, and it's an interesting question because I had a similar question when I first got here and went to Olmsted. We're using the same technology there. We've advanced it. Now we're using steel wickets, and there'll be a little bit more scientific piece to it, but they're still manual. You still pick them up and you drop them. So really what the key is the technology works. And the reason this dam is different than a lot of others, we've got 8 other locks and dams up the Ohio, at least in our footprint. That doesn't consider further up the river. They don't use this because they were differently designed dams. Because this hub is so critically important and so busy, that's why they went with a navigational pass or the ability to pass traffic without going through a lockage most of the year. That's huge because what industry will do when the dam is down and they can just go open river is they'll come configured with larger barges than they would if they had to go through the lock chamber. And that's really key when they come to push to Paducah or somewhere that they don't have to get through a chamber. So to circle back on your question, the technology is still very valid. The challenge is this infrastructure is just really old.
So speaking about the technology, raising 1 or 2 or 5 wickets, does that, if you can't raise some of those, does it make it more difficult to raise the others, or how does that connection work? Not
necessarily. The only time that those two things correlate is when you end up with a hole. If we have a gap or a hole that's 1, 2, or 3 wickets wide, we're fine. Because as you can see the boat now, that's how we raise them. They butt up against the wickets and they slide right along the face of the dam to work. So if we end up with a gap of more than 3 wickets, you can't reach out far enough and get there. So if you can't get one up, it doesn't necessarily mean the one next to it won't go up mechanically, but the issue becomes where we can't slide the workboat further down the dam.
Is it easier to maintain and fix wicket dams because it's piece by piece and manually lifted and lowered?
I don't think I'd say it's easier to fix. It's a challenge. For these guys out here to raise or lower that dam, depending upon conditions, can take 8 to 12 plus hours. So I think if I said it was easy for them, some of them would come running out of the building right now. It's a challenge. It's got a lot of benefits. There's a good reason to have this navigational pass like this. Like I said, it allows us as the Corps on the river to pass a lot more traffic when the dam is down. There's a lot of validity to having this type of design. But it is a challenge. A lot of our other dams don't necessarily have the manual labor that these guys do in raising and lowering the wickets, but they can't pass quite as much traffic because it's all going to go through the lock chamber.
It's fairly dangerous to raise and lower the wickets or to fix them by hand, correct?
It's a challenge. These guys do extremely well, A, at doing the task, but B, also being safe about it. And that's something we've talked about, particularly with this latest operation. There's nothing that we should do that should threaten a person's life. It's high risk. You're standing out on the edge of the barge. The water this morning through those wickets was probably going more than 6 feet per second. So if you get sucked through there and you fall off the barge, it could be significant. So it's inherently dangerous, but these guys do a very good job. They always wear their safety equipment, and they really do a good job of looking out for one another. Because that's the key is you do this for so long, so many years, you got to be sure that you don't get into just muscle memory and do something that you shouldn't do. And they really do a great job starting the day with a good briefing to be sure that we're safe, and then watching out for one another to be sure that we don't do something incidental on the barge that gets somebody hurt or killed.
So in fixing it, did you have to use divers to fix the dam?
No, when the water's going that fast through, you can't dive in that. Now, the portion where the boat is right now, there will be divers in the water today to do a little bit of that work, but that's not fixing, that's just operating of the dam.
Okay.
Any other questions? Well, again, I really appreciate you all coming out today. I'm very glad that it's a good news story that we'll be able to pass industry in about 8 to 12 hours. The team down here has done unbelievable. I again want to thank the cooperation from the Coast Guard, TVA, industry, and a lot of other stakeholders that made today successful. So thank you all for your time. Appreciate it.